This study guide for the pre-calculus midterm. I'm going to go through as much as I can. I don't have a graphing calculator on this computer right now, so when I say I'll give you the steps on how to solve certain problems using your calculator, so bear with me. This particular first problem is easy. All you're doing is looking at the graph. The graph of f of x is 1/10 x to the 5th. Looks like this, right? And what is the domain of the function? And the domain is, of course, any x value you can put in, and it will have some sort of output. And with this type of function, there are no asymptotes, so it doesn't get split up, right? And it's not only on one side of the graph or the other side of the graph. It goes infinitely in both directions. So the answer to this one is A. Okay? You see, it can't be 0 to infinity because there's part over here that goes into the negative x realm, right? So that would go away, and the same thing holds true for D. It's that they're only talking about half of the graph, and there's no asymptote. Even if I zoomed in, you would see that there is a value. If you put in a 0 for x, you would get out a 0. So it does exist in this function. All right, I'm not going to keep talking about this. All done. It's going to be a very long video. Solving our radical functions is super simple. Super simple. You have radical 6x minus 2 equals radical 4x. Sorry about my writing. I'll get there. Takes a little while for me to get the hang of it. Basically, what you're going to do is square both sides, right? And by squaring both sides, all you're doing is getting rid of the radicals. How do you undo a square root? Square it. All right. So if I square both sides, what I end up with is 6x minus 2 equals 4x plus 4. And then I'll just do some simple algebra. I'll subtract 4 from both sides. Subtract 4 from both sides. Why would I do that? Don't do that. I mean, I could, but I don't want to. I'm going to add 2 to both sides. Woo! Why not make it easier on ourselves? And subtract 4x. That's what I meant. Subtract 4x. Don't make fun of me. Everybody makes mistakes. Oh, what a horrible line. 6x minus 4x is 2x. And that's going to be equal to, because that goes away, that goes away. 4 plus 2 is 6. And then we're just going to divide both sides by 2. Oops. And x, of course, equals 3. Done. Next, few, okay? Which describes the end behavior of this graph. Now, what you can do is put this function into the graph. But those of you who already know what a cubic function looks like, by the way, it was the one that, it looks very much like the one you saw earlier. It looks just like that function to the power of 5. It looks like, here's your x and y axis. Whew. I'm drawing like a clown today. And cubic function goes something like that. Oh, God, I wish I could draw. Anyway, there it is. It looks like that. So we're going to start looking at end behaviors. The limit of x as x approaches negative infinity, as we go farther and farther and farther left, what is happening? Well, it's going down, 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 infinitely down. So if I go left, it's going down, so that can't be true, right? As I go left, it goes down. Oh, well, this makes sense. This is good. So it's good on this side. So let's check this. As x approaches positive infinity, it's going infinitely upward. So actually this part of it is not true. So both f and g are gone. We want down and up. We want negative and positive. Our answer is H. Let's just check J. Yeah, this means it's going up on the left, and that's not true. All right. For number 5, what is the greatest possible number of real zeros? You check the lead the lead exponent. There we go. And that lead exponent is 3. Therefore, the possible real zeros are 3. And the greatest number of turning points, well, look at this. If I have a cubic function, this is a quartile function, but if I have a cubic function, I turn once and I turn twice. That's the greatest number of possible turns you have in a cubic function. So let's look at this quartile function. If you put that into your calculator, it'll look something like this. It'll look sort of like a W, and let's go ahead and mark the turns, all right? So it turns here, and it turns here. So what are the greatest possible number of turning points? That's 1, 2, 3. So it would be F, 3. And what do we know about that? You can just take that lead exponent and subtract 1. So that's how you get through that. Moving on, I have 3 more. This is the same type of problem, so I'm going to go ahead and do some work. All right, we're going to do some synthetic division, and we're going to use synthetic substitution. Now, the difference between the two is synthetic division, you have to put, instead of a positive 2, a negative 2, because we put the root, or the opposite of positive 2 in the box, right? We know how to create the box. And I'm going to leave that box there and then do the math. So inside the box, we're going to put a negative 2. This is synthetic division. Then I'm going to put the coefficients going down in succession. So there's a 1, x cubed, 5, x squared, 5, x, and negative 2 is my constant. I am going to draw a line. Where are you, little buddy? I think that's this. That's a shape. Help, I need to draw a line. Can't find it. There it is. I'm going to draw a line here. Sorry it took so long. Wow. Draw a line here. Create my remainder box. And here we go. Get rid of that. Now we're drawing again. All right. Synthetic division. Sorry that took so long. Step 1, drop down the 1. Step 2, multiply negative 2 times 1. You get negative 2. Now add these two things together, right? So we get a 3. 5 plus negative 2 is 3. Now multiply again. Negative 2 times 3 is negative 6. All right. Add them together. 5 and negative 6 is negative 1. And then last but certainly not least, multiply negative 2 times negative 1. We get positive 2. Negative 2 plus positive 2 gives me 0. Oh, look at that. It is a factor of that polynomial. All right. So what do we have left over? 1, 3, negative 1. Now, I started with a polynomial to the power of 3. So I'm going to drop that power by 1, put an x squared in, plus 3x minus 1. What's left over? X squared plus 3x minus 1. Is that one of my answers? And absolutely it is. There you go. All right. So let's do it again. All right. It's going to take me a little bit, to erase. Oh, it's not going to be perfect, guys. Sorry about not being perfect, but it's going to take me a little while. And there. One last thing to erase. I should just use my eraser function on the pen, but I'm not that smart. Okay. So let me get rid of this. Get rid of this. Get rid of this. Now we're writing again. Now we have a function here. Easy peasy. All we're doing is putting the function here. And we want to know what's happening after 0.5 seconds. Now, synthetic substitution, you put the actual value in there. We're going to put 0.5 in there. Last but certainly not least, we're going to put in negative 16, 35, and 6. And what we get as a remainder is going to be the answer to our question. And we did this in class. Drop down the negative 16. Multiplied that by a half, which is negative 8. We came down with 20, I think it was 27. Then half of 27 was 13 and a half, if I'm not mistaken. And then 19 and a half is our remainder. Is 19 and a half one of our answers? Yeah, it's right there. It's letter A. So let me get back to square one. I'm just going to keep talking. Find the remainder when 2x cubed plus 6x squared plus 3x minus 1 is divided by x minus 1. Now, we're dividing, so we're going to go back up here and use synthetic division. Now, if I'm dividing by x minus 1, I'm going to put a plus 1 up here. And I'm going to put my 2 here, my 6 here, my 3 here, and my minus 1 here. Okay? Now, drop down the 2. Multiply 1 times 2, you get 2. There's an 8. 1 times 8 is 8. 3 plus 8 is 11. 1 times 11 is 11. 11 minus 1 is 10. Is there a remainder? Yes. So the question is, what's the remainder? There's a remainder of 10. Therefore, no, it's not divisible by x minus 1. All right. Oh, wow. Here we go. This is the one of the first ones that you're going to put into a calculator, this type of question. It says, for a period of x days, the balance can be modeled by this particular function. So we have a function of x cubed minus x squared minus 8x, and we want to know for what days, how many days, for x days, when is the balance $60? So you're going to input the function, you're going to go to y equals on your calculator, you're going to put in this function, this right here, oh God, sorry about that. You're going to put in x cubed minus x squared minus 8x, right? And then you're going to hit second graph, and that'll bring up a table. And you're going to find 60, where your output is 60. Okay? And by the way, it's at 5 days, right? Day 5. Good? Any questions? You just ask me when I see you in class. I'm going to get to the next page. Population question. The population, they're okay. let's go ahead and this is an easy population question. This is an easy interest question. Really, population is equal to original n times 1 plus r to the t. Okay, so we have t. What's the population of 2017? Find the difference between 2008, 2017. So t equals what? 9 years. 9 years. I don't have a calculator near me, so this is going to be very difficult to do. I'll show you how to set it up, and then you just hit the button in your calculator. Population, we'll use n for population. So n is the original population, which is 800. And we have a rate of 7% a year. So r is 0.07. All right. So when you type this into the calculator, you're going to do 800 times 1 plus 0.07 is 1.07 to the 9th power, and that'll give you your answer. I don't have a calculator handy, and I can't really reach one, so I'm not going to do that. Okay? Now you know how to do it. Moving on. Logarithms. Cool. Here's logarithmic form. Here's exponential form. Here's logarithmic form. All right? So you're going to take something in exponential form and just rewrite it. What this says is that 2 to the negative third is 1/8. When we write it in log form, we're going to write it as log, log. The base is going to stay the same, but we're going to make it a log base. Log base 2, the answer, and then the exponent. It says, what base 2, what power of 2 gives me 1/8? Okay, -3. So that's how you evaluate that. Again, evaluate this log. So log 9. What power of 9 gives me 1/81? This is wonderful. We know that 9 squared is 81, but it happens to be the reciprocal of 81, which means it has to be a negative exponent, just like the one above. So we're going to say -2, right? 9 squared is 81, but it's the reciprocal, 1/81, therefore it must be -2. Put that away. We'll move on to the next one. Now we're getting into trig land, right? I want to do one thing first before I start on these questions. You will have a question on your test that says, find, oh God, sorry about that. Find, or write, let's say, I said 66 yesterday, right? 66 degrees in radians. And I did, all right? And so all you do is 66 degrees multiply by pi over 180. And that gives you 66 pi over 180, which then gives me 11 pi over 30. And remember, if you get to here, partial credit, full credit right there. So that's that. We already remember that. I'm not putting the formula on the test to convert because you should know that already. All right. So last, well, I've got two problems, right? No, that won't go away. I guess too many deletions. There we go. So what do we have here? We have if the tangent is 5 over 12, and it's in the first quadrant or the fourth quadrant, what is the value of sine? Right? Okay. Well, if tan is 5 over 12, tangent is opposite over adjacent. So you have to remember it. I'm not going to give you this stuff. Opposite over adjacent. So if I have a triangle, I know it's not drawn to scale, 5 over 12. Sorry about that. What is sine? Well, we know that sine is opposite over hypotenuse. What don't we have? We don't have the hypotenuse. So we're going to use Pythagorean Theorem, which is 5 squared plus 12 squared equals c squared, or hypotenuse squared. 25 plus 144 equals c squared. That is 169 equals c squared. I just happen to know, take the square root of both sides. Uh, 13 equals c. Right? Okay, so now we have the opposite value. We had it before. The opposite is 5. Here's theta. What's across from it? 5. We have the hypotenuse of 13. So now we can write sine. So the sine is 5 over 13. It's going to get a little noisy because you guys just came in. So don't get upset. It's your fault that it's noisy. I'm just trying to get this done. Last and certainly not least, I'm going to go ahead and use this space. So I got to get rid of this. Get rid of that. Get rid of that. All right, find the exact value of tangent. Well, we knew that tangent is opposite. Oh, sorry, let me use a different color. We know that tangent is opposite over adjacent because theta's right there, but we don't know the length of the opposite side. So we have to do some more Pythagorean theorem, but we're not being given b squared or opposite squared. So we're going to say 8 squared plus b squared equals 12 squared. Right? All right, 144 is equal to b squared plus 64. Well, this is kind of cool because we can just go back here. Subtract 64 from both sides. Nice and easy to do the math. That's 80 equals b squared. Take the square root of both sides. Square root of 80. Oh my gosh. Let's see. 80 is root 5. That's fun. So we can take in a 4. Let's give it a 20. You can take out another 4. So 16 times 5. 4 root 5. Right? Cool. So b is 4 root 5. Sorry it took so long. You can simplify that radical. I'm just using root 5 because it's up here. Okay. Now, there's the bell. You guys are starting work. I'm going to finish this up, and I will create a second video in case I have to cover a class. With 4 root 5 being our opposite side, 4 root 5. All right, so opposite over adjacent would be, I got to write this in a different color, tangent. So tangent theta is 4 root 5 over 8. Can it be simplified? Yes, both 4 and 8, right? So it would be root 5 over 2. All right, I'm going to stop the video here. I'm going to make a second video to finish up. Be back with you soon.